Welcome to my presentation. In this presentation, we shall see how to solve a real-world application problem. Let us say we have a situation of this kind. We have a rectangular fence in our backyard. Let's say we have a rectangular fence in our backyard like that. The long side is 15 feet and the short side is 12 feet, and we are planning to fence this backyard, and then we want to know what is the total amount of fencing we require. So we can use our place value chart to be able to find out the total amount of fencing we would require. We want to find the perimeter of this rectangle. How do we find the perimeter? Let's write down some steps. Step number one. The perimeter, let me write it down here. Perimeter is, we're going to let me erase this. Let me erase this part of it here. And then perimeter means when we start from one point and when we walk along, let's say we start at that corner, and when we walk along the outside border of this figure and then come back to the starting point, that is what the perimeter means. So the perimeter for this particular figure will be a long side plus the short side plus the long side plus the short side. So since we have two long sides and two short sides, we're going to add up all the four lengths, and that is what the perimeter is. So we know the long side, we know the short side. The long side is 15 feet, and the short side is 12 feet, and the long side is 15 feet, and the short side is 12 feet. So when we add up all these numbers, 15 plus 15 is 30, 12 plus 12 is 24, 30 plus 24 is equal to 54 feet. So therefore, we would require 54 feet of fencing to cover this backyard, which has a long side of 15 feet and which has a short side of 12 feet. So this is the way we want to be able to solve the real world application problems. Let's take another simple example. Let's say this time we are dealing with another type of a situation. Let's say you have $1,524 in your checking account, okay? And before making a deposit of $875, let's say you are by your part-time job, you're able to get $875, and you're adding this $875 to your amount which is already existing in your checking account, which is $1,524. Let's say you're adding $875 to your checking account, okay? We want to know what is the amount in your checking account after you made the deposit. So what do? We're going to use our knowledge of the place value chart and then be able to add these numbers. We're going to write them out as follows. We'll write these numbers as 1, 5, 2, 4, and then the second number is 8, 7, 5. So let's draw these lines just for us to make sure that we are placing these numbers in the right location. The first number here is in the ones place. This is the ones place. This is the tens place. This is the hundreds place, and this is the thousands place. And now we are ready to add these numbers. We add the numbers in the ones place. We add the numbers in the tens place. But we add the numbers in the hundreds place, and so on. So always we want to make sure that when we when we arrange these numbers in these place values, the ones line up, the ones numbers line up, the tens numbers line up, the hundreds columns lines up, and then so on. So in the ones column we have 4 and 5, so 4 plus 5 is equal to 9, there is nothing to carry over. Then we move on to the tens column. 2 plus 7 is equal to 9, there is nothing to carry over. So in the hundreds column we have 5 and 8. 5 plus 8 is equal to 13, so we carry the 1 to the thousands place and write the 3 in the hundreds column, and we have 1 in the thousands column already, so we add the 1 which we carried over, and therefore the number is equal to 2. So therefore when we added $875 to our already existing $1,524 in our checking account, the balance came up to $2,399. This is our answer. This is the way we want to be able to solve the real world application problems. In my next presentation, we shall see some more real world application problems.